Hello students, welcome to the cbse chemistry lecture series. Last class we discussed about isomerism. In that isomerism we discussed structural isomerism. Under the structural isomerism, chain isomerism, position isomerism, functional isomerism, metamerism and tautomerism. Now we are going to discuss about stereoisomerism. Under the stereoisomerism, what is meant by stereoisomerism? Stereoisomerism is nothing but the stereo means the arrangement of atoms in three-dimensional space. Arrangement of atoms in three-dimensional space. So under the stereoisomerism we have two different types of isomerisms are there. One is a geometrical isomerism. Another one is a optical isomerism. Let us discuss one by one. First we will take a geometrical isomerism. What is meant by geometrical isomerism? Geometrical isomerism, suppose if you are having a compound like CH3, CH, double bond CH, CH3. In this case, we are going to write CH3, C, H, double bond, H, CH3. Here in this case, the carbon-carbon double bond is restricted in free rotations. The free rotation is whereas if it is a single bond, the free rotation is possible. Whereas in this case, the carbon-carbon free rotation is restricted because of what? Presence of double bond. So that is why this CH3 and HH on same side, you have to say is a cis isomer. Suppose if you are writing this one, CH3, C, H, double bond, H, CH3. Same group on opposite side. Same group on same side. Same group on same side, same group on opposite side. And then it is called trans isomer. Trans. What is the name of this compound? This compound is a cis and but. Secondly, we are having a double bond, so you have to say 2-butene. Cis 2-butene. Here it is what? Trans 2-butene. Okay, this is an example for geometrical isomerism. In this geometrical isomerism, okay, in this geometrical isomerism we have somewhat we can call as what? EZ notations. This is similar to cis-trans isomerism. But when we have to use this EZ nomenclature or EZ notations, suppose if it is a CH3, C, Cl, okay, double bond, C, Br, CH3. Okay, this is an example for 2-bromo, 2-chloro, but 2E. So this case, if you write a CH3, C, Cl, double bond, C, CH3, Br, correct? Now you have to give 1 and 2. So when we have that higher atomic mass, we'll have the 1. So chlorine and C, chlorine is having only what? Here it is a 17, here it is a 6. So you have to give the preference is 1, this is 2. Here you have to say this is 1, this is 2. 1 on same side, then it is called Z nomenclature. The Z is nothing but Suzaman. That means together. Same group on same side, that type of things only. Whereas in this case, if it is a E, is a nothing but is a trans. CH3 C Cl double bond C CH3 Br. So this is 1, this is 2, this is 1, this is 2. 1 on opposite side we have to use the letter E notations. That means intergen. That is means opposite. So this is an extension of what? Geometrical isomerism by using the notations E, Z nomenclature. Okay. The next we are going to discuss about optical isomerism. What is an optical isomerism or optical isomers? So you have to think about when an organic compound having a chiral carbon. So organic compounds must having a chiral carbon, or you can say asymmetric carbon. Chiral carbon or asymmetric carbon. Second one, it must be having a non-superimposable mirror images. Non-superimposable mirror images. So what it means? The organic compounds must satisfy these two conditions. It must having a chiral carbon, asymmetric carbon, and second one non-superimposable mirror images. First we will explain what is a chiral carbon. What is meant by chiral carbon or asymmetric carbon? A carbon attached to 4 different groups. 4 different groups. Then the carbon is known as a chiral carbon or asymmetric carbon. So I will give an example for this case. You can take a compound like this, CH3 C H OH COH. See, this carbon atoms are attached to 4 different groups. One is a CH3, another is OH, then COH, then H. Then this is carbon is what we can having the symbol asterisk symbol is nothing but is a chiral carbon. Okay, then this compound will show optical isomers. Then second condition is what? It must be having a non-superimposable mirror images. So the same compound we have to represent the form of Fisher projection formula. That is what? COH CH3 HOH. If we have a mirror here, you write the mirror image COH, then OH, H, CH3. And this will rotate the plane polarized light to clockwise direction. Then it is called dextroform. This will rotate the plane polarized light to anti-clockwise direction. So this is what? Levo-rotation. Or you can say simply L notation. This is what? D form or L form. And these two compounds are called optical isomers. Optical isomers. Or you can say enantiomers. So what are enantiomers or what are optical isomers? Organic compounds, okay, will having a satisfy the two conditions. It must be having a chiral carbon or asymmetric carbon. The another one, it must be having a non-superimposable mirror images. So in this case, if you take the compound, if you take this compound and what overlapping here, this H and OH will be there. That is called non-superimposable. Suppose if you have that what? These two will be on like this. Then it is called superimposable mirror images. When this compound is what? Keeping like this, then it's a non-superimposable mirror images. Okay. So thank you students. If you have any doubts, please mention in the comment box. Thank you students.